Okay, so we will start today to do review problems on chapter 2, to do a practice on what we have seen together. So in the first problem, we want to determine the magnitude of the resultant force Fr, which is equal to F1 plus F2, and its direction measured counterclockwise from the positive x-axis. So here, they gave us two forces, F1 and F2, with their magnitudes and the angle they are doing. F1, they gave us the angle with Y. F2, they gave us the angle it's doing with X. Now, we have several methods to solve such problem. We can use geometrical method by using the triangle law and cosine law, and we have the analytical method. We will do here both, and sometimes if in a problem they force you to choose one method, you should go for it. Okay? So first, if we want to use the analytical method, what should we do? We decompose first each force into two components. Okay, so I start by F1. As you can see here, F1.
Doctor, analytical means the rectangular components, X
Yes,
and Y.
exactly. Yes, the rectangular components method. Yes, it means that I take a frame, I divide my vectors into components, and I add them. Okay, this is the analytical method. So F1 from the figure, F1 vector, is equal to F1 magnitude times sine theta along I, and plus F1 cosine theta along J. Okay, because it's cosine along J since the angle theta is between F1 and Y axis. Now for F2, if I decompose, as you can see, F2 will have a positive projection on X, but negative projection on Y. So F2 vector is equal to F2 cosine phi along I and minus F2 sine phi along J. So in this way, I got the components of F1 and F2. Now, to get the resultant, F resultant, all I have to do is to do the summation, okay? So along I will get in total, I will replace by numbers. So F1 is 250, so it's 250 sine theta, which is 30, 250 sine 30, plus F2 cosine phi, so plus 375 cosine 45. This is along I. And along J, we have for F1, it's 250 cosine 30. And for F2, it is minus 375 cosine sine 45. Okay? Along J. As you can see here, we will have a positive component along I, okay, and a negative component along J. So the force we will have will be like this. If we represent it now, I think this will give a negative result. Okay, so it is like this. It is in the fourth quadrant. Okay, and I need to give, they are telling me to find the direction from a counter. Can anyone verify the calculation of this number, if it is positive or negative, please? Because cosine 30 is radical 3 over 2, while sine 45 is radical 2 over 3. So in case it is, Yes.
Minus 48.
Okay.
Yeah.
Minus 48. So it is negative. Okay. Very good. So I should find this angle to determine the direction, okay, with the positive x-axis. Since they want me to measure it counterclockwise from the positive x, since it is in the fourth quadrant, this means that it will be a negative angle, okay, because the clockwise direction is the positive one. So this is the counterclockwise direction, which is the positive. Since the angle is in the opposite direction, then it's a negative angle, okay? So I will put theta as negative, and to find the value of theta, the absolute value of theta, of this angle, let's call it, because we already have theta, we can go list here angle beta, okay? So to find angle beta, what can we do? We just say that,
Tangent minus 1.
yes, beta is
Y
equal to
over x.
tangent minus 1 of here. If you want, you can keep it as it is because it will give you directly a negative result. So tangent minus 1 of fy f resultant y over f resultant x. In general, we take the absolute value because we know the quadrant and just we want to take the absolute value of the angle. But here, since they want, they are asking for the sign because they are saying, express it relative to the counterclockwise direction. So we don't put absolute value. It will be minus the angle we get. Will be so when we do on the calculator tangent minus 1 of a negative result, it will already give us a negative angle. Okay, but even if it's give a negative angle, we have two choices. It can be like this. It can be in the first quadrant or in the second quadrant. How to choose which one? How to know which one to choose? We should look at the figure. Okay, so this result, for example, will give you an angle, but it will be also applicable for, because you know that the tangent function is periodic and the periodicity of it is pi. So when you get an angle, you can have beta plus pi. Okay, how to choose? You should know in which quadrant your resultant is. Since you know that your resultant is in the fourth quadrant, you just put, so if you get, for example, minus 10, it's minus 10. If the vector was like this, in the opposite direction, opposite sense, same direction. So if you are in the second quadrant, which angle you choose if you want to measure it from x? You choose the angle you got. So let's say this is minus 10. If you are counting from here, it will be 180 minus 10. Okay, so it's very important to know in which quadrant I am to be able to give the angle. Now, concerning the magnitude, for the magnitude, it's very simple. So it's radical of fr x squared plus fry squared. Okay, any question on the first method, on the analytical method? Okay, so now let us move to the second method, the geometrical one. If I want to use the geometrical method, I should first construct geometrically the resultant. I can use parallelogram law, I can use triangle law. Okay, so let us see how to do it. So let's say I want to use the parallelogram law. I already have the two forces starting from passing by one point. So this is F1, this is F2. So if I complete the parallelogram, I get the diagonal, okay? So if, let us complete the parallelogram. So if I draw a parallel to F2 like this, so as you will see, when you construct your parallelogram, it will be also equivalent to constructing the triangle, because look, this is F1 and I did a parallel for F2, so this is F2, okay? So from here, from the triangular method, if I join the first point of F1 to the end point of F2, I get the resultant. Also, which will be also the diagonal in the parallelogram. Okay, so this is my resultant starting from this point to this one. Okay, so this is FR. Now, in order to find FR by geometry, okay, I need to find angles. What I know until now, I don't know any angle in the triangle. I just know that the magnitude of F1 here is 250, and I know that the magnitude of F2 here is 375. So I will try to find an additional information to be able to calculate FR. So I will try, since you have two lengths, try to find the angle in between. So it will be interesting if I can calculate this angle. Okay? So I should look at my figure to see how can I determine this angle. To do this, okay, you know that in a parallelogram, these two angles, this one and this one, okay, that are on the side of one edge, the summation of them will be equal to what? This one and this one.
180.
Very good, 180. So if I can find this angle, I can deduce this one. Okay? How to find this angle? Look at your figure. It's simple. You know that the angle here is 7. The angle here is what?
Pi over 2 minus
Minus 5. Very good.
5.
It's 90 minus 5. Okay? And as you can see, this is here. This is a flat angle. So the summation of these three angles will be equal to what? To 180. Okay? So what I can write, I will call this angle here. This angle I will call it alpha. Okay? And the one here I will call it beta. So first I will find alpha. To find alpha, I say that 180 is equal to 90 minus 5 plus theta and plus alpha. Okay. Now if I replace, I know angle, I know the value of theta. Okay. So I can calculate alpha. So alpha is simply alpha will be equal to 90 plus 5 and minus theta. Okay, and since phi and theta are given, I can replace numerically. So it's equal to 90 plus 45 minus 30. Okay, so it is equal to 105. Okay, now since alpha plus beta equals to 180, okay, then so I deduce that. So beta is equal to 90 minus 5 plus theta. Okay, so because if you do 180 minus 90 minus 5 plus theta, you get 90 minus 5 plus theta. Or you can, since you have already calculated alpha, you can directly say that it is 180 minus 75. It's equal minus 105. It's equal to 75. Okay. So now, once I get this angle here, which is beta, it's done. How to find FR now? Which law I will use?
Cosine law.
Very good, cosine law. So F resultant is radical of, as you can see here, it's radical of F1 square plus F2 square minus 2 F1 F2 cosine. This is beta. We demonstrated together how to find it. This is beta. It's 90 plus theta minus phi. It will give you 75. Okay. Just a small remark here. In their problem, they converted the force into a mass. What does this mean? So it's not a very usual presentation, but what they did to get this, first here you have English units. So if you replace by 250 and 375, you will get the resultant force in LB. And for me, it's fine to do it in LB. Don't do anything. So if forces are in LB, keep the resultant in LB. No need to convert. But here they converted first to Newton. So from LB to Newton, from English system to SI. And then a certain method to present a force is to give the equivalent mass. Because, for example, you know that if I have a weight of 200 Newton, it will be equivalent to which mass in general if I'm talking about G10? In
We
general,
divided by
yeah,
9.
so I can say that W is equal to 20 kilogram. And this is a method. Sometimes we represent the force by the mass, the equivalent mass. Okay? It is not very used, but just for you to understand why they got this. Okay? So if you convert to LB, you will get your same result. Okay. But we are not done here. Pay attention. When we want, they still need to find the angle measured counterclockwise from x-axis. So what we need to find is our figure is not very accurate. Why? Because the resultant force will be from the lower side. Okay. So if you want to do an accurate figure, it will be somehow like this. It will be nearly like this. Okay, and this is after. Okay, since when we did calculation, it was clear that the resultant force has a negative component. Okay, so maybe like this. Okay. So nearly this is, I will put it larger a little bit for you to see it. Okay. So let us do it like this. Maybe here the figure will be clearer for you. Let us go down. Yes, here it's clear. So as you can see, if you draw the diagonal, it will be little bit lower than x. So you are in the fourth quadrant, okay? And you want to find the angle using the geometrical way. So how to do it? First, I know that this angle here is theta, okay? And we have calculated together this angle. We call this angle here. We called it beta, I think. Here they use different, okay, they use different notation, it's fine. What was this angle? 75, okay? We already know that this angle is 75 degrees. And we know that the length of F1 is known, okay? And we know the length of FR, but we still need to define the direction of FR. To define the direction of FR, we should find its angle with one known direction, okay? So here first, if I can get this angle here, okay? Once I get this angle, if I want to deduce, I can deduce this one. Why? Because look, this angle is divided into two parts. Part 1 here, and this is part 2. Part 1, I know it. What is part 1? This angle here is equal to what? Look at your figure. You know that the angle here is equal
to 90 minus that.
Exactly, it's 90 minus that. So this part is 90 minus theta, okay? So if I am interested in the second part. So what I can do, I can calculate the whole angle here, this whole 1 plus 2. And when I find 1 plus 2, I can subtract 90 minus theta, so I get the small angle, okay? So what is my strategy now? My strategy now is first to find this whole angle, and then subtract 90 minus theta. Okay, how to find the whole angle here? Which law I will use?
Sine law.
Very good, sine law, because now I know all the lengths of all edges in my triangle, and I know one angle, so I can use the sine law to find the other angles. So if this is 75, what can I write? I can write that the edge opposing angle of 75 is the resultant force. So I can write FR over sine 75, okay, which is 90 plus theta minus phi, is equal to, okay, is equal to F1 over, if you want here, if you want to find this angle directly, what should we do? You have two possibilities, or you calculate this angle, or you calculate this one. Both will give you the result you want. Because look, if I want to work with this angle, I will call it angle X. Okay, what should I write if I want to find X? I will write it's equal to F2. This is equal to F2 over, because the opposing edge to this angle is F2. So it's F2 over X, okay? Over sine X. So it's F2 over sine X. So in this way, I can calculate angle X. And once I calculate angle X, this angle here, the one here, I will put it like this, okay? This angle will be X minus X minus the angle 90 minus theta. Okay, this is a first method to get this angle. Another way, if you want, is to do it from the other side. So if I consider this small angle beta, okay, the other strategy is to calculate, if you want, if I am able to calculate beta and I know this angle here, this angle, why I know it? Because I know
It's
phi
phi.
here. Yes, I know phi. So this will be what? This whole angle here will be 90 minus phi. Okay. So this is 90 minus phi. So if I'm able to get beta, I can simply say that the small angle here is.
Doctor, isn't it phi itself?
Sorry, yes, it's phi, exactly, because I thought phi is from this side. Yes, exactly, it's phi itself. Okay, because look in the figure, they defined phi as the angle between x and f2 directly. Yes, exactly. So this is phi. Okay, this is given to be phi. Okay, so if I calculate beta, then the small angle here can be calculated in another way. I can say that this small angle is simply phi minus beta. Now, how to calculate beta? Also, I can calculate beta from the triangle, from the sine law, okay? Because look, I can say Fr over sine 75 is equal to F1 over sine of the opposing angle, which is beta, or I can write it as F2 over sine x. And both methods will give me, of course, the same angle, okay? So in both ways, I will get the same angle here, the small angle here. But pay attention, since I want to express it. So here I will put it, or I will put minus, because I'm considering the counterclockwise as positive. Or you can just put this. You can put near the beta this presentation. You know, it is in the clockwise. Okay. But to be accurate, since they asked for to express the angle in the counterclockwise direction, so you can put the counterclockwise direction and just put that it's a negative angle. So you put minus the result you get. Okay. So here, if we want to see the calculation, it's clear in the figures that it is a very small angle. Here they didn't do it, but you should do it. And they are missing a step. They should find this small angle. So to finish your problem, the value of phi was 45 degrees. So this is 45 here. Okay, and you got beta 37.89. So you can put just this. So if I consider the counterclockwise as positive, so the angle of interest will be 37.89 minus 45. Okay, and then you can get your answer. Okay, so it's nearly it's equal to, so if I do 45 minus 38, it's nearly 7 point or 6.11. Okay. No, it's just 1 second. 5, 3, 8. Yes, so okay, it's minus 7.11. Okay. Any question on this?
Clear.
So if you don't have a question, so let us move to another problem. So in this problem, the vertical force F of 350 lb acts downwards on A on the two-membered frame. Okay, find the magnitudes of the two components of F directed along AB and AC. This is nearly the same style of problems we have done together. Okay, we have done a problem very similar in the course material. So please try to practice with this problem because we have already done it. We have done nearly the same one. So try to do it numerically and make sure that you will get the same result. Okay. Another problem. Boom OA carries a load P and is supported by two cables as shown. The tension in cable AB is 732 Newton. Determine the tension in cable AC and the magnitude of P if the resultant of P and the forces exerted at A by the two cables must be directed along OA. Okay. So what do we have here? We have a point A subjected to several forces. You have a vertical downward force P. You have a tension in cable AB. And as I mentioned before, whenever you have a cable, the cable is always in tension. Okay? So if my cable is in tension, then how A will act on it? A will act on it downward. And by action reaction, the cable will act on A upward. Okay? So if I do the same analysis for AC. So since A is pulling the cable down, then the cable will do on A an action that is up. Okay. So this is TAB. This is the tension in AB. Okay. And this is the tension in AC. Now, the question is that I want to, so let us go back to the question, okay? They gave me the tension in AB in magnitude, it's given. TAB is known, but TAC is not, okay? And they gave me an additional information to find the tension in AC. They said that if the resultant, I have two unknown. I have the tension in cable AC to find, and I have also the magnitude of P to find. So I want to find magnitude of P, and so I have two unknowns, tension in cable AC, magnitude of P, in order to have, okay, the resultant of these forces along OA. So this is the information they gave me. How can I write this information? So I have three forces acting on A, which are P, TAB, TAC. And I know that if I do the summation of these forces, the resultant will be along OA. Okay? So let us write together on the figure what we know. We know that TAB is 732. So I just put on the figure that this is equal to 732 Newton. Okay? And for the other force, I don't know it, TAC, so I will just put it as TAC, and I should calculate it. And I know that the resultant of these forces is directed along OA, so I can present also the resultant force. So this is FR. Whenever I have a 3D problem like this, okay, what I should do, I write the vectorial equation. What is the vectorial equation I can write? I can write that F resultant as a vector, okay, is equal to the summation of TAB vector plus TAC vector plus P vector, okay? Now, I will start to express each vector. For FR, what do I know about FR? Do I know the magnitude? No, but I know the direction. So how can I write vector FR? Who will tell me? How can I write the expression of vector FR? It's equal to what?
Can you
FR
write it as
equals
yes?
It's minus FRI, okay? Because look, it's directed along x-axis in the negative direction, okay? So it's minus FRI. So first I can replace FR vector by minus FR times I vector, okay? Equals to, for TAB, how to express TAB as a vector? If I know the magnitude, what should I
the
do?
magnitude multiplied by the unit vector.
Very good. So it's the magnitude, which is 732, times the unit vector of AB. So, okay. Now, concerning TAC, it's the same. But for TAC, I don't know the magnitude, so I will put it as unknown. So I will put plus TAC times unit vector of AC. And for vector P, it's what?
Minus J.
Very good.
Minus PJ.
Exactly, it's minus P J. Very good. Okay. So now I have three unknowns in this equation. I have TAC, and I have P, and I have FR. But it's very fine for me. Why? Because you know that in 3D, this vectorial equation will give me three equations by comparison along I, along J, and along K. So let us do together the work in detail. So I have three unknowns, FR, TAC, and P. And I want to calculate these three unknowns. Okay? So I will write here, since we have three unknowns, we need three equations, and these three equations will be already here because it's a vectorial equation by comparing. So we need three equations by comparing along I, J, and K. Okay? Now, what is the next step to be able to compare along I, J, and K? I should find unit vector of AB and unit vector of AC. Okay? And as usual, to find a unit vector, it's very simple. The first step is to get the coordinates of points. Okay? So let us look at our figure. For point A is on x-axis. Okay? So I can simply say that coordinates of A are 0.96, 0, 0. These are coordinates of A. For point B, as you can see here, if you follow the dashed the lines, okay, B is in plane YZ. So I can say that the coordinates of B are 0 along X. You have along Y, it's a positive component, and also along Z, it's positive. And as you can see from the figure, the component along Y is plus 0.58, while the component along Z is plus 0.48. And for C, I have positive Y component equal to 0.5, but negative Z component equal to minus 0.72. Okay, so for B, I can write it's 0.55, 0.58, sorry, 0.49.
48, doctor.
Sorry, 0.48. Okay. And now, for point C, it is 0, 0.5, and minus 0.70. Okay. So now I am ready to get unit vector of AB and unit vector of AC. Okay. If I want to find unit vector, so first for unit vector of AB, it's equal to AB vector over magnitude of AB. So it's AB vector over magnitude of AB. It's equal to, for AB vector, you know that I do XB minus XA along I. So first, what is X of B? It's 0. Okay, so 0 minus 0.96 along I. Okay, plus along J, what do I have? I have 0.58 minus 0. So it's plus 0.58 minus 0 along J. And along K, I have 0.48 minus 0. So plus 0.48 minus 0 along K. So I get it's equal to minus 0.96 along I plus 0.58 along J and plus 0.48 along K. This is unit vector of AB. In a similar, but don't forget to divide by what? شنو نعمل? I should not forget to divide by
the magnitude.
of AB. So here, what I will do, so always don't forget this. Okay? So now I will divide my result here. So I put in brackets this result, and I will divide by over radical, okay, of 0.96 square plus 0.58 square plus 0.48 square. Okay, so now what I will do now, okay, I will do the same for unit vector of AC. Okay, so let us see here, it will be